Let's add a digital readout to this Proxxon FF230 teeny tiny mill. This here is a capacitive type of digital readout. You can find these really inexpensive on the internet. First thing I want to do is size it appropriately for this table. I'm going to cut it down a bit. That's going to prove a little bit challenging because not only is it hardened stainless steel, but the capacitive strip, it's made out of glass. Now I figured the best tool for this job would be a wet tile saw, but I don't have one of those. I got this Proxxon chop saw and a Lennox Metal Max diamond blade. It's more optimized for cutting metal. The diamonds are a bit on the coarse side, so hopefully it's not going to chip this glass strip too much. I'm going to have to keep it wet manually. Got a little bit of distilled water here. It seems to work, but it's going to be really slow going because I do not want to build up heat. It'll be a little bit at a time like that. Well, that was a rather protracted cut, but we're through, and it's quite clean, really. I was afraid that the glass would chip, but it didn't. There is a little bit of a burr. I took care of that with a jeweler's file. It's no longer stainless hardened, it's just stainless hardy. However, at least it's the right length. Awesome. The mounting hardware for this digital readout is a little bit crude. It's just stamped sheet metal. It's rather inelegant. I'm going to opt instead for drilling some holes and mounting it directly. I broke out napkin CAD, and there is where I would like to put the holes. I set up the mill and I used an edge finder to locate the first one. Seeing that this is hardy stainless steel, rather than using a drill bit, I'm going to use a carbide end mill for putting the hole in. Gotta use a lot of cutting fluid. Hopefully this cutting fluid's not going to interact with the glue holding in that capacitive strip. I'm going to use the lever feed rather than the fine feed so I can sort of get a feel for it. Let's go. Bit squealy at first, but it's going well now. Ooh, and we're through. Yeah. Now let's reposition for another hole. A vice stop is a really handy accessory to have for repeated operations. I have a video on my channel where I confabulate it. Make sure you check it out. All you gotta do is now stick the piece in there, the part, and push it up against the vice stop, lock it down, and we're ready to drill another hole in the right location. And we now have 4 holes for M2.5 screws. What we need next is to make some angle brackets to hold this digital readout in about this location. And here's the stock that we're going to make the angle brackets from. This here is 416 stainless steel, a magnetic variety, 1.5" by 3/8, and I've roughly indicated where the angles are going to be. And I have to cut this with my portable hand-operated bandsaw. I think this is going to require some extra special concentration and consternation, and I do this off a camera. And here are the 2 angle brackets from the bandsaw. As much as I like to think that I'm getting pretty good at sawing by hand, they still need quite a bit of cleanup. I'm going to start off by milling off this surface and this surface, just a tiny little bit of material, maybe 1/10 of a millimeter or so. I already have one of them clamped onto the machine table. I'm using these toe clamps, which are really fantastic for pressing the part down onto the table and making sure that it's completely parallel. These 2 surfaces are now milled smooth. The next job is to mill this surface to be parallel with this raw edge. So now this side is milled flat. The next is to turn it over, put it in the vise like so, and take care of this raw finish here. Not only is it raw, but it's domed. About 4.5 millimeters thick. We'll also thin it out down to around 3.5. Sounds about right to me. And the next task would be to mill these two surfaces flat. However, these legs are a lot longer than they really need to be, and they're going to get in the way of the end mill. So I roughly marked with a Sharpie how I would like this to be cut down, so that it situates the digital readout about in this location. Now this is less than an ideal clamping situation because there's nothing supporting, no parallels underneath this angle bracket. The reason why is I need to get it straight off of that face. So hopefully it's gonna, as I have it clamped down really tightly, and hopefully it's not gonna go out of whack. I'll stop the mill every now and then, just make sure that it's still square. There goes nothing. And now we can surface both of these faces with one pass. A different end mill installed, both angle brackets in the vise at the same time. We're going to now clean up these legs, even them out, to smooth out those bandsaw cuts. Let's go. So here are the two angle brackets largely finished in size. Now I've been a bit loose with my measurements, and just in case you'd like to repeat a project like this, and for posterity, let's get these measurements down. This arm here is about 36.6 millimeters in length. Anywhere between 36 and 37 should be fine. This one here is 23.4 millimeters, I think that is. So somewhere between 23 and 24 millimeters would be good. Originally it was 3/8 inch, whittled it down a tiny bit, but it's still a bit more than 9 millimeters in width. This thick arm, the short arm, is a little bit more than 4 millimeters in thickness here, 4.4. And the thin arm is 3.1 millimeters in thickness. Now, what I'd like to do next is I want to whittle down a little bit of this thick arm up to the line that I scribed here. Let me get the light in there. Up to that line there, which is measured about 4 millimeters. What I would like to accomplish is to make a heel on the corner of this L bracket, and that will register with this rule groove here and support the weight. Now, in order to machine this, I figure this clamping setup should do the trick. I got a setup block in here. If I put these two angles at opposite ends of the jaw, that should clamp it down solid enough for milling. It's not really supported too well, but as long as I'm using a nice sharp end mill and I'm just taking small little bites at a time, well, fingers crossed. And now the angle bracket's basic shape is done. There's a little bit of a heel there. Let us test fit it. Does it register nicely with this little rule channel? Perfect. Registers perfectly. Next up, I'd like to put two shallow flat bottom holes in that location on this angle bracket. The holes are going to be about 6.5 millimeters in diameter, and I just roughly sketched out that is where I would like them to be. So I have an edge finder installed, and I've already located on the fixed jaw of the vise, which would be that surface right there of our part. I then moved the spindle so that it is centered at that location, 4.65 millimeters in. Next thing we need to do is find this edge of the workpiece and move in 5.25 millimeters. Now this edge finder, let's see how it works. We turn it on, it's on the lowest speed, and then over here, this setting wheel, we zero it like so, and then with the hand wheel, we push the workpiece into the edge finder, and you see it's starting to make contact now, and that eccentricity is lowered a little bit. Now we keep pushing it in until it kicks out. Let's just watch when that, oh, right there. Now we are at the edge of the workpiece plus 3 millimeters because the diameter of this edge finder is 6 millimeters. So now we're on target. I got a 6.5 millimeter end mill installed. I got the vise stop also set up so that we can do a repeat operation on the other angle. I got here a 6.5 millimeter end mill installed. Now for depth I need 2.7 millimeters, and I can measure that by following the gradations on the fine feed for the Z-axis. But just to be extra careful, I have a dial indicator set up as well to keep an eye on things. Okay, let us try this out. Zero, which should touch. There we go. 2.7 millimeters. First hole complete on both angles. Time for the second one. Moved 8.5 millimeters over. Now, despite this dial indicator jumping around like crazy, it proved to be more accurate than the gradations on the fine feed mechanism. Fine feed mechanism was reading about maybe 2.9 millimeters, while the dial indicator was 2.7. And just check this hole out here. And yeah, look at that. It's 2.7 on the money. Well, let's do another set of holes. Next, I like to put a hole for an M2.5 screw onto one of these angle brackets on the heel. I made a little sketch here to indicate where I would like the hole to be. It's 2.05 millimeters nominal diameter, and I have an M2 end mill installed. I put some cutting fluid onto the workpiece. We are at the highest speed, and I'm just going to start the hole. An end mill is good for starting a hole and actually staying on target with this mill. I do find that this collet is it's a little bit it's very imperfect, and with drill bits, well, good luck with getting a hole on target. So let's get this started and just go in maybe a couple millimeters. Now, if it was a bigger bit, I'd want to have a clamp here to hold this part and make sure it doesn't get knocked off kilter. But this is going to be such little forces, I'm not worried about that. Now a 2.05 millimeter drill bit, and we're going to drill this about 7 millimeters deep. Next, I like to add a very, very small countersink. Give it some fluid. There we go. I'm just going to do this by eye. It's really not critical. I just need like maybe 1/4 of a millimeter of relief on this. that, maybe just a little bit more. That'll do it. And on to tapping. Now let's add some M2.5 threaded holes to these angle brackets to mount this scale onto. Now I'm not going to use any sort of precise location here. Instead I'm just going to press this up against the vise fixed jaw like so, and I already adjusted the table. I think that this will be more than adequate precision for this purpose. Dribble a cut-in fluid. And here we go. And tap. Remember to back off every now and then just to clear the chips with these tiny little taps. Very easy to break. No problem. Now let's cut these screws down a little bit to about 7 millimeters in length. I'm going to use my screw cutting jig. You can check out the video where I make that. Subscribe. Let's go. And now the linear scale L brackets are finished and we're ready to check out fitment. These wells will accept these little 1/4-inch neodymium magnets. Let's drop a few of them in. Oh, come on, going straight, not sideways. There was 2 of them. And there's 2 more. And now this just fits on, registers with the groove, and fits on like that. Next, what we need to do is affix this measuring head to the y-axis, and I figure a similar L bracket with a magnetic attachment for this machine face would do the job. Now I have this bit of scrap from earlier on in the project, and I figure that I can adapt it for that purpose. And here's the end result. Up top, we got some scrap material available for future projects. Over here is some hardware, and here are the machined angle brackets. Let's start off with the hardware. We got 2 Phillips screws, M3 screws that came with this digital scale, and they are for mounting a bracket onto the back of the measuring head. These screws are a little bit long, and they interfere with the movement of this measuring head, so I had to provide my own M3 washers to go along with them. Over here is a countersunk M2.5 screw, custom cut to an overall length of about 6.5 millimeters in length. That is an M4 washer that will go along with that screw. And over here are the screws that we cut down earlier in the video, M2.5 with a threaded length of 7 millimeters. Now here are the brackets that we machined for much of this video, and they turned out quite nicely. I'm quite happy with them. Let's not forget that there's this hole there that is threaded. Hint, hint, we'll see the purpose of that shortly. Now this bracket, I did not make a video of its production because frankly it was basically the same procedures as we already saw in the video, so we didn't need to do that again. A difference is that the magnet pocket is on the inside face rather than on the outside face of this angle, and the exact dimensions of these holes, they're a little bit different. They're just made so that they register nicely with this measuring head like so. Now let's throw these machine parts into the tumble vibe. There's green plastic pyramid medium in here, just ran dry. I have found that about 12 hours in the tumble vibe works wonders. It makes the parts have a nice matte finish, obscures some of the machining marks, and although I do deburr the parts as I'm making them, take off those sharp little edges, the corners of these are still quite hard and not finger friendly, and the tumble vibe does very, very slightly relieve the edges. So anyways, 12 hours and a lot of noise. And the angle brackets are out of the tumble vibe, and they look really nice. That really puts a good finish on. I've already stuck the neodymium magnets in an hour or so ago with some crazy glue to keep them from popping out. Now, if I was to do this project again, one thing that I would do different is these arms that hold the magnet, I would make them thick like this bracket. This is too thin. Let me demonstrate with a magnetic film viewer card. You can see the magnetic flux is permeating right through this thin metal, and when it is installed on the table, magnetic swarf is going to collect there. On the other hand, a nice and thick arm like this with some more metal, well, that's completely shielded, so any little metal particles are not going to be sticking there annoyingly. Anyways, let's get this put together. And of course it assembled easy peasy. Despite my rough positioning of these holes on these two brackets, it's right on the money. In fact, this here is completely flush with this edge of the guide. Yeah, these custom screws, they are also just perfectly sized. They come right to the edge like so. Over here, we finally see what the purpose of this hole in the heel was. It is to mount a washer, and the washer is going to allow this assembly to be located on the side of the table. And now all we need to do is slide the measuring head over until it engages with the magnet on the y-axis like so, and we turn it on and zero it, and we are ready to now digitally read out on the Proxxon FF230 mini tiny micro mill. That is really cool. Now let's just test something. Let's zero it, and let us test whether we can remove this and then stick it back and get back to location. I made it easy to remove because very often on such a tiny machine, I'd want to do some operation where this might get in the way or get dirty or something like that. And a lot of machining operations, you don't actually need a digital readout, but when you do, you do. Now let's try this out again. Line it up on the table like so, slide it into position, and we're out 1/100th of a millimeters. That is completely acceptable. Let's just try that again. Okay, pop it back into position, slide it over. Now it's back to zero. That is awesome. Anyways, thanks for watching. Subscribe, and I'll see you next time. Bye-bye.